So today we're going to be talking about special review. This is factoring practice number 2. Some things that we are going to be able to do, of course, always check for greatest common factor of a polynomial. Identify a binomial as a difference of squares, factor using the difference of squares pattern, and factor a perfect square trinomial. So those are the things we're going to do. Now I'd like you guys to pause and identify your squares. So fill that table in below, pause, and then come back and check your answers. Okay, welcome back. I'm hoping that you have these as your answers. I didn't want to bore you in the video. Okay, so these are just things that you really need to have a heads up about, so that if you see them, you'll recognize them. Okay, so this right here is the difference of squares pattern. Okay, so this is the difference of squares pattern. You can see that this is a perfect square, this is a perfect square, and this is the difference symbol, taking the difference of those perfect squares. Now, once you identify what is being squared at the beginning, you can put that same A in the front of both of your binomials, and then you find out what's squared at the end, and you put that same B at the back of your polynomials. Now, for this pattern, you're going to have one that's plus and one that's minus, because the only way to make a negative b squared is to have one positive and one negative. Also, when we multiply this through, we would get a squared plus ab minus ab plus b squared. Or sorry, not plus b squared, minus b squared. So you can see how those middle terms will go away, right? They're going to go to 0. And so that's why you need one positive, one negative, and both factors basically the same. One's a sum, one's a difference. Okay, so first, of course, we always look for greatest common factor. And I'm going to kind of make myself a little bit closer to this stuff. Oh, gosh, I'm having to deal with this, huh? Okay. So the first thing we want to do is see if there's anything in common. Well, there's no value here. And there's no variable in the other one. So since there's no value here and there's no variable in the other one, there's nothing in common, okay? So now what we're going to do is we are going to see if we have perfect squares. So we're going to identify perfect squares. We already have the difference. So you can see that the first one is just x being squared, and the second one is a perfect square, which is 4 squared. So immediately we see difference of perfect squares. So we make our two factors, one with a plus, one with a minus, and it doesn't matter which one you put first. And then the first term would be an x, because x times x gives me x squared. And the last term would be a 4, because 4 times negative 4 gives me a negative 16. And so that's how you're identifying that we have the difference of perfect squares, and then using the perfect square pattern, the difference of perfect square pattern. Okay, so now what we're going to do is we're going to look at this first one, and it has a 4 in it, and the last one is 16, and that has a 4 in it, but it doesn't share any variables. So let's go ahead and take the greatest common factor out first. So this will be 4 times x squared minus 4y squared. Okay, so just like the other stuff, whenever we take a greatest common factor out, we're definitely going to drop that in the bank, because that's going to be part of our solution. Now we have to identify if we have perfect squares. So we see that this is a perfect square with x being squared. We have a difference, and then what would be squared to make 4y squared? Well, 4 is made with the 2 times 2, and y squared is made with the y times y, so that would be 2y. So we would put our two factors down, one with a plus, one with a minus, and we would put the x first and the 2y second. Now, you can notice how we might be able to go a little bit further, but we're always going to look at the one that's the difference and see if we have perfect squares again, which in this case we do not. Okay. All right, we have another one. Okay, so first we're going to look for greatest common factor. This is made by 5x times 5x, and this is made by 4y times 4y, or 2 times 8. Well, basically there's no 5, right? And there's no x. And so we don't have that. And even though we can see that we do have perfect squares, this is not the difference. So this is prime, or it just can't be factored. Okay. All right. Zooming in gives me really thick writing, huh? All right, let's look for another one. Okay, so first of all, we look to see if there's anything in common between this and this. There's no value in this one, so it's just whether they both have y's, and they don't. And so now what we're going to do is we are going to see that we do have the difference. And so we need to see, is this a perfect square? So this is a perfect square with 4x squared squared. And this is a perfect square with y squared squared, because 2 times 2 will give me 4. So now that we have the difference in perfect squares, we're going to make our two factors. One with a plus and one with a minus. The first term is 4x squared. And the last term is y squared. Now, just like the last one, we're going to see if we can go any further. And we're really only looking at this one because it's the difference. And we see that this is a perfect square and this is a perfect square. So we can keep going. Now, what we're going to do is we're going to put 4x squared plus y squared, because it is going to still be a factor. But we are going to identify that this is really 2x squared minus y being squared, and we do have the difference of two squares. So actually, let's move this down a little bit to give us a little bit more room. Oh, that's funny. Hold on, I meant to grab that tool. I guess it's not grabbing it that easily. And so when we do that, we're going to now put our two factors from our difference of two squares. And we're going to have 2x plus y and 2x minus y. And then you can look one more time, but it's clear that there's not perfect squares there. So we are done factoring. So we always have to make sure that we are finished factoring by the end. Okay, let's look at the next one. Well, the lowest number is a 2. And the question is 2 a factor of 50? Because they both don't have x's and they both don't have y's. And the answer is yes. I can factor a 2 out, and I'll get x to the 4th power minus 25y to the 4th power. So we're going to basically be dropping 2 down in the bank, right? And now we need to look, because we see that we have a difference. We need to see, are these perfect squares? So this is x squared squared, and this is 5y squared squared. Now I'm showing you what's going on in my brain. You guys are not always going to have that work right there. Plus and minus. The first one is x squared. The second one is 5y. Let's zoom out a little bit so we can, I guess let's zoom in. And then the first one is x squared again. And the second one is 5y squared. Let's clean this up. This is really super messy. I'm not a fan of that. Okay, let's actually make our little... Okay, so we have this is going to be... Oops, darn it. This is the two factors, one with the plus, one with the minus. The first one is x squared. The second one is 25y squared. And then we know that this is a sum, so it's going to go down in the bank. But we see this one right here as the difference of two squares. So we're going to go ahead and factor that one more time. And so we'll have, we'll have one that's a plus and one that's minus. And we'll have x plus 5y and x minus 5y. And we look at the last one again, and we notice that it is a difference, but we're not going to have two squares, so we're finished. So wow, we have a lot of factors on that one. We have the 2, and we have those 3 binomials. All right, cool. Okay, let's try another one. And always remember that you guys can always pause and then do the problem, right? Okay, here we go. So 3 is the smallest number, and we see that 3 is a factor of 27. They both don't have x's, they both don't have y's, so 3 is the only thing that can come out. And we're going to get x to the 4th plus 9y to the 4th. well, that's cool. Because I got to take the 3 out, it's not going to be prime. But then I noticed that I have a sum, not a difference. So even if those are perfect squares, and they are, we're finished. So because we took the 3 out, because we factored the 3 out, it is not prime, but this is the way it is factored. Okay, so key there is watching out for addition and subtraction. I'm going to move that up a little bit. Okay, so let's talk about what would happen if I had 2 of the same binomials multiplying, right? So if I was looking, and I'm going to do a plus b times a plus b. Now you can see how those are the same. And if I multiplied this out, it would be a squared plus ab plus ab, and then plus b squared, right? Well, this is actually a squared plus 2 of these, because they're the exact same, plus b squared. So you can see how the middle term is there. So when I have 2 of the same factors and not one of opposites, then we're going to get another pattern. So I could either have a plus b squared, or I could have a minus b squared. But if I have a plus b squared, it would be a squared plus 2ab plus b squared. So the difference here is if I have a plus here, I have positive in the middle. And if I have a subtraction here, I have negative in the middle. So that's just like something to look for. Okay, so we're going to be able to first identify these perfect squares. We're going to be checking the middle term for 2ab, and then we're going to factor using the sign of the middle, right? Because the sign of the middle is going to be 0. Now, you can see how these are all trinomials, and so we still have to look for the greatest common factor as we go. Well, 4 is the number, in the lowest number, and it's only made from 2 times 2 or just 4, right? Well, that's okay with the 20, but it's not okay with the 25. So there's not going to be anything in common between this whole thing. So now I need to look at what is the sky of perfect square. So this is 2x squared, and this is 5 squared. So we do have perfect squares, but the question is, if I took my 2x times my 5, do I have 2 of those in the middle? So 2x times 5 is 10x. And sure enough, I do have 2 of those in the middle. So as soon as I see that, I can make 2 of the same thing or with the same sign. You can either write it like this, or you can write it like this. Okay? The first thing that squared was the 2x, and the last thing that was squared was the 5. Remembering, if we have 2 of the same sign, then that's the sign in the middle, right? Okay, let's look at this one. So we look at all of these things and we see 9 is made by 3's. 24 has a factor of 3, but 16 does not. So there's no common factor. And so now we have to identify, is this a perfect square? And it is 3x. Is this a perfect square? And it is, it's 4 squared. So the question is the middle 2 times the 3x times the 4? And guess what? It is. It is. So as soon as we know that, we're going to be able to put 2 with the same sign, and it'll be the sign of the middle, because we have twice as much of that. Or you can put it as 1 square like that. And the first thing that was squared was 3x. And the last thing that was squared was 4. And remember, you guys can always check these by multiplying them out. It just makes your homework a little bit longer. Okay, so some of you might be asking, should we do it like this or like that? And I don't care. Either way is fine with me. Okay? Either way is fine with me. All right, but you do need to be able to recognize them if it was a multiple choice. Okay, let's do the next one. The smallest number here is 9, and 9 is made with 9, 3, or 3, right? So since 25 is not made with any of those, there's no common factor. We always have to check for that, though. Okay, so the question is the first one a perfect square? And it is. It's 5x. Is the last one a perfect square? And it is. It's 3y. So as we look at this, we're asking, is our middle one 2 times 5x times 3y? And so yes, 30 is 2 times 15, xy. So this does work. So we're going to make 2 of the same exact factors, and since the middle has a negative, it's going to be negative. And we could also just write it like this. The first thing that was being squared was 5x. The last thing that was being squared was 3y. So we could write it like this, or we could write it like 5x minus 3y squared, like that. All right, well, there you go. There's your examples of your perfect square trinomials and your difference of squares. All right, take care, you guys.